All right, welcome back everybody. In this video, we're going to move on to our next unit, our next trigonometry topic. And the next thing we're going to talk about in Unit 4 is, we'll say trigonometric identities. Okay, what the heck does that mean? And I suppose more importantly, why are we looking at these? How is that helpful? Well, that's the first thing I want to do is talk about how this relates to what we've done before, and then hopefully how this is helpful as we're dealing with trig through the rest of the semester. All right, so let's do this. Let's try to relate this new topic, trigonometric identities, to our last unit, our graphing unit. And what I'm going to do is I'm going to graph these three different equations on my calculator. Okay, we didn't actually get into more complicated graphs where you're mixing sines and cosines or you're squaring things like these examples. So we'll let our calculator do that. I'm going to pull my calculator up. I already got these three plugged in. If you want to pull yours out and follow along with me, go for it. Otherwise, you can just watch here. Okay, I'm going to graph these one at a time, so just my sine functions highlighted. And one trick I'm going to do to start things off with is I'm going to go down to my zoom and highlight zoom 7, which is zoom trig. And what that's going to do is just give me a nice scale to work with for my trig functions. Okay, and what I have first is just my sine function. It looks like it's counting by pi over 2's. So again, zoom trig just gives me a nice scale to work with. Okay, so there's the graph of sine. We could graph that by hand. What I'm going to do next is I'm going to get rid of this sine function and just graph this more interesting function here, this 2 cosine x minus 3 sine of 2x. And as you can see, when I make different combinations of sines and cosines, I get more interesting, more complicated curves. Okay, that's the point I want to make here, is we can make stuff more complicated by combining sines and cosines together. Okay, let's go back and let's graph this third one though. So I'm going to get rid of the second one on my screen and graph the third one. Okay, sine of x to the third plus cosine x squared times sine x. And when I graph this one, I get something pretty strange. Right here, this is kind of a big, ugly, nasty trig function. But when I graph it, what does it look like? Well, it just looks like a sine function. Okay, so what it looks like here is it looks like that sine squared x plus cosine squared x times sine x is just equal to a simple sine x. Okay, we will prove this is true, not in this video, but actually the next video will be one of the first things we're going to do. But what I have here is the basic idea of an identity. It's two expressions with usually one more complicated that are equal to each other. Okay, now when it comes time to working with trig, the question is, would I rather deal with this more complicated left side or easy to write right side? I think it's pretty clear if I had the option, I'd rather just work with the right side here. Okay, so with identities, the idea is that we can take stuff that's ugly, that's complicated, there's a lot of stuff going on, and hopefully reduce it down to something a lot simpler. Okay, that's the big thing we're going to be doing for this unit, is taking complicated trigonometric expressions and reducing them down into something simpler. And that's what we're going to start off with in Unit 4.1. Okay, we're going to say fundamental identities. What we're going to do here is look at kind of the basic ways, the basic approaches to taking a complicated trig expression and making it simpler. Okay, so let's get going with that. To start reducing trig expressions, we're going to need some tools to work with. Okay, I'm going to call these the fundamental identities. Okay, there are 6, we'll say, reciprocal identities and 2 quotient identities. So we're going to start off with 8 of them. And when I say these are identities, what I mean is that cosecant x is equal to 1 over sine x. What we mean by an identity is that these two expressions are equal to the same thing. They mean the same thing. They're just different ways of writing the same thing. Okay, now with these reciprocal identities, notice that the cosecant and the sine match up together, just like we've been talking about all semester long, whether it's by definition with the graph, same thing here. Secant and cosecant go together, cotangent and tangent go together. And then notice that the cosecant identity and the sine reciprocal identity are really just opposites of each other. So yes, I'm giving you 6 here, but if you can remember the first 3, okay, there shouldn't be an issue remembering the other 3. Okay, as far as the quotient identities go, okay, tangent we're going to say is equal to sine x over cosine x. Well, that's just the opposite of cotangent, which is cosine over sine. So once again, if you can remember one of these, I think it's pretty easy to remember the other one. Okay, these identities are going to be the tools we use to simplify more complicated expressions. Now, first thing I want to do before we start using these identities is show you why they work, how they work. I want to prove one of them's true for you. Okay, you don't need to copy this down. You can just watch, and basically we're just saying don't take my word for it. Let's prove why tangent x equals sine x over cosine x. I'm going to start with the right side of the equation. Let's say sine of x over cosine x. Okay, now what is that equal to? Now, by definition, we said that the sine of x in a right triangle is equal to the length of the opposite side over the hypotenuse. So I'm going to write opposite over hyp for opposite over hypotenuse. And same idea, the cosine we define as the adjacent over the hypotenuse. Okay, so when I say sine over cosine, we really mean opposite over hypotenuse over adjacent over hypotenuse. So I'm dividing two fractions. Let's divide them. Dividing fractions is the same thing as multiplying the first fraction, so opposite over hypotenuse, times the reciprocal of the second fraction. So adjacent over hypotenuse flipped upside down will just be hypotenuse over adjacent. And in doing that, notice I have a hypotenuse on the denominator and numerator, so I can cancel those out. And what I'm left with then, if I multiply across the top, multiply across the bottom, is opposite over adjacent, which by definition is the tangent of our angle x. Okay, so that's why tangent x equals sine over cosine. I could basically do the same thing with the other 7 basic identities. I'm not going to do that here, but I just wanted to show you why this works the way it does. All right, so let's use those fundamental ideas to simplify trig expressions. Okay, that's what we're doing in problem 1, part A here. We've got a fairly simple trig expression, and the first kind of plan of attack I'm going to show you is going to be just to switch everything into sines and cosines and then cancel common terms out. Okay, that'll be something that shows up in a lot of the different techniques we show you over the course of this lesson. Okay, so the first thing I'm going to do is I'm going to rewrite this expression in terms of just sine and cosine. Now I've got most of my fundamentals identities over here. Okay, I'd recommend have that list handy as you're getting used to this. Eventually you want to memorize them, but we'll leave them here for now. And I've only got the first 3 of my reciprocal identities. Typically we're not going to rewrite sine, cosine, and cotangent in terms of cosecant, secant, cotangent. We will go the other way around though. So first thing, tangent x, I'm going to rewrite that as sine over cosine. And then times cosecant x, I'm going to rewrite that as 1 over sine. Okay, so now I have everything in terms of sines and cosines. The reason I want to do that is if everything's in terms of sines and cosines, I'll have a good chance of being able to cancel things out. And in this case, there's a sine on top and bottom, which I can get rid of. So if I then multiply across the top and bottom, what I'm left with is just a 1 over cosine x, which we can simplify further. Rather than saying just 1 over cosine x, we can call this just a secant x. Okay, that is my answer. That is my solution. That is what cotangent x times cosecant x reduces down to, is a secant x. One thing we'll show you, why did I go about this the way I did? Now my tangent, I could have wrote that, I don't have the identity up here, but I could have wrote that as a 1 over cotangent x. Okay, that was on my previous page. And I could have said that cosecant was still 1 over sine x. If I did it this way, nothing's going to cancel. I can't do anything with it. That's why we use just sines and cosines. Okay, since every function can be written in terms of sines and cosines, that's going to leave you with the most stuff to cancel out. So this step would be correct. That's the way I could have started this problem, but it's not going to get me anywhere. That's why I'm using just sines and cosines here. All right, problem B is the same idea. Why don't you take a minute, pause the video, see what you can do with it, and then hit play to either check your answer or to kind of show you what to do for the next step if you get stuck somewhere. All right, let's show you how to go through part B. Okay, again, pretty simple expression. And again, I just want to write everything in terms of sines and cosines here. Secant u, we can say is 1 over cosine u. Cotangent u, we can say is a cosine over sine. And then sine u is already in terms of sine and cosine. It's just the sine. The trick with this problem is I don't need to rewrite that. I'm just going to leave it as sine u. We'll say sine u over 1. Because again, I want everything in terms of sines and cosines. That's going to be what makes the most stuff here cancel. Okay, so with this one, I've got a cosine on top and bottom that cancel. I've got a sine on top and bottom that cancel. Whenever everything cancels through division, we're left with just a 1. Okay, meaning that this expression, this trig expression here, is just a fancy way of writing 1. No matter what my angle is, I'll get a 1 when it's all said and done. In problem 2, we're going to look at some trig identities with division involved. This is going to be just like a little extra step added on to what we were just doing. Okay, so part A, we have cosine times tangent over cosecant. Only thing we've shown you how to do so far is write everything in terms of sines and cosines. Let's start with that. Cosine x is just a cosine x in terms of sines and cosine. So I'm going to write that as a cosine x over 1. So we need equal signs here. And tangent, we said, is sine over cosine. And then that's all over a cosecant, which we can rewrite as a 1 over sine. Okay, so we have everything in terms of sines and cosines. Now I have some fractions within fractions, or division of fractions. I can take care of that division. I'm just going to write the cosine x as is for now. And then let's divide these two fractions. Remember, division of fraction is just the first fraction right side up. So sine x over cosine x. Times the second fraction flipped upside down. So 1 over sine x will turn into a sine x over 1. So we've got rid of the division and turned it into a multiplication problem. Here we're just back to what we were doing in the last problem, problem 1. I'll cancel the cosines out because they're on top and bottom. And then I can't cancel my sines out because they're both in the numerator. But what I can do is multiply them together. Sine times sine is, we'll say, sine squared. So I'm going to say sine squared x. Now notice I wrote the squared on the sine, not the x. That's just something to do with trig to show that the whole thing's squared, not just the x. Okay, but anyways, we just showed that this kind of ugly looking trig expression with fractions in it is the same thing as sine squared of x. Again, there's an example of division. Problem B is the same type of problem. Once again, why don't you hit pause on the video, try to work that one out yourself, and then you can click play to either check answers or for me to get you unstuck if you get stuck somewhere. All right, let's go ahead and run through part B. Same idea, trig expression with fractions. Step 1, convert everything to sines and cosines. Cosecant x is just the 1 over sine x. Cosine x is just a cosine x. We'll say cosine x over 1. And then that's all divided by cotangent, which we can say is cosine over sine. Okay, a couple things we could do here. I could combine the numerator fractions first and then have just division of one fraction, but I'm just going to write this all in terms of multiplication. For the stuff in the numerator, I'm going to leave right side up. I'm going to say I have a 1 over sine x times a cosine x over 1. Okay, and then times the denominator flipped upside down, so we'll have the sine x on top, the cosine x on bottom. And then from here we can just cancel. There is a cosine on top and bottom. Those will go away. A sine on top and bottom. Those will go away. So what I'm left with, once again, is just a 1. Okay, that is a common answer you'll get when you're simplifying trig expressions. In other words, this big ugly fraction we started with is just a fancy way to write 1. All right, I'm going to call that part 1 of lesson 4.1. We'll get in some uglier stuff in the next part, but for now, let's say start working on the homework. Make sure you're okay with the basic multiplying and division problems. And I guess the other thing is start getting comfortable using those fundamental identities. It'd be a good idea to start memorizing those as well. Okay, get help if you need it on that first stuff, and then once you're done with that, you can dive into video 2 and start working on the more complicated stuff.